Hello, welcome to the second half of this lesson. We're going to talk about the composition of functions as they relate to inverse trig functions. So let's just review what a composition of function looked like before we do trig. So let's say that I have f of x is equal to, I don't know, x plus 1. And we say g of x is equal to, let's say, x squared minus 1. If I would ask you to find f of g of 3, what that means is 3 is our initial input. That input goes into the g function first. So that means I would have to take 3 squared minus 1, 9 minus 1, and 8 becomes the output. So this was my original domain value. Then this was my range value. And what happens is this guy, he does double duty. The range now becomes the new domain, and now I'm going to put that into the f function. And so when I take 8 plus 1, I get a final range value of 9. So that means the point 39 would be on the graph of the composition of f of g of x. In other words, it's basically a substitution machine. So what I do want to show you is, let me erase some of this so I get some space back, is we found out that f of g of 3, we just discovered that that was 9. Well, if I want you to find g of f of 3, all right, let's talk about that. 3 would go into f. So 3 plus 1 gives me an output of 4. That range value becomes the new domain value. And it goes in as 4 squared minus 1, which gives me 15. So what's really clear is there's no way that f and g can be inverse functions because we didn't get the same value when we put in 3 when we went in both directions. Look at what happens if I would change this. All right, let's redefine f of x to be x plus 1. Let's redefine g of x to be x minus 1. If I wanted to find f of g of 3 now, all right, 3 would go into the g function, so that would be 3 minus 1, which gives me 2. And then that 2 does double duty. It goes into the f function. And wow, notice I got 3 back. And if I do g of f of 3, all right, I'm going to put 3 into the f function, which outputs 4. That does double duty. And then I put it into g, which is 4 minus 1, and I also get 3. Now, this is not a proof by any stretch of the imagination. If we wanted to prove these were a composition of functions, we would have to take the composition and show that they were equal to the identity function. But what happens if f and g are inverses is that the input and the output are the same. So hopefully that gave you like the juices flowing on that background of when did you do compositions back maybe in a previous class. And now let's apply them to inverse properties. So when I look at these, since these were inverses, what a lot of kids might do is if they know that f and g are inverses, well, they just kind of cancel. I know I'm going to get 3. But you have to be very careful when it comes to doing this with inverse trig because you have domain restrictions on many of or all of your trig functions. So here's what our inverse properties say. If x is in the domain and y is in the range, then if you take the sine of the arcsine of x, again, provided this is true, then yes, they cancel and you get x. Yes, they cancel and you get y. Yes, they cancel. Yes, they cancel. Yes, they cancel. Yes, they cancel. But this is when you have to be careful. Let's say that I want to take the arcsine of the sine of 4 pi over 3. If you get into cancel happy, oh, the sine and the arcsine are inverses, they undo each other. The cosine and the arccosine, they're inverses, they undo each other. The tan and the arctan, inverses, they undo each other. If you get into that habit, you're going to be in a heap of a mess because ultimately, if you look at this problem, the arcsine, this is an arcsine problem. You have to remember that the domain of the arcsine has to be between -1 and 1, and it's only going to output angles that are between pi over 2 and negative pi over 2. 4 pi over 3 is not in that range of values. So if you decide that, oh, the arc sine and the sine cancel and you're left with 4 pi over 3, you're incorrect. So there is an answer to that. I'll come back. Let's look at some examples. All right. If you think about this, the arc tangent of -5, the domain of the arc tangent is all real numbers. And it's going to output a value that I'm going to be able to take the tangent of because it's all real numbers. So the one thing you can do is on the tan of the arctan, they do cancel out. This is equal to -5. But when you do the arc sine of the sine of 5 pi over 3, let's think about this. And you do not have to do your problems like me, especially I know that I'm teaching to a bunch of kids I might not even know. But if I put 5 pi over 3 into the sine function, all right, 5 pi over 3 is down here. And I know that this is going to be actually, it's probably more like here. It's going to be a short x and a long y in a negative direction. So I know that the output of that is -√3 over 2. But then I'm going to have to put that value into the inverse sine or the arc sine. And when you take -√3 over 2 and you put it in the arc sine is only defined in those two quadrants. So I'm going to be in the fourth quadrant and it is going to be there, but 5 pi over 3 assumes you go this way. And we've talked about in earlier lessons that your inverse sine is defined between pi over 2 and -pi over 2. So this actual location going to a negative angle, final answer is going to be a -pi over 3, not 5 pi over 3, because that is not a range value of your arc sine. Please be careful on choice C. This was, I will have to say that this is a trick problem that a teacher might give to mess with your head. All right, so remember, something that I sometimes teach my kids is, for instance, if we look at a previous problem, when I take the sine of 5 pi over 3, let me erase all of that. It's kind of a mess. All right, 5 pi over 3 is an angle. It is going to output a value. When I take the arc sine of the value, I get an angle back again. So the answer to this expression is an angle. In this problem, pi is the argument of an inverse cosine. So this is not an angle. This is a value. So we're saying take the inverse cosine of 3.14. Well, my domain has to be between -1 and 1. 3.14 is not in that value, so there is no output. If I try to put pi into the inverse cosine, all of these inputs have to be between -1 and 1. It is not, so this answer is undefined. Now, if I was going the opposite direction, all right, if I asked you to take the inverse cosine of the cosine of pi, now this is an angle. So what is the cosine of pi? The cosine of pi is -1. And what is the inverse cosine of -1? It's pi. So that's why when you do these compositions, you have to know your domain and ranges of your trig functions and of your inverse trig functions. You need to keep track of, is what they're giving me an angle or is it a value? And if you need to, I know it might seem goofy, but I do have some kids write your little boxes to kind of go through the process, the composition process. All right, so the first type of problem that we just did, these have all been tan of an arctan, arc sine of a sine, cosine of an inverse cosine, where they're the same. The next two examples have to do with when they're not the same, like we're dealing right now with the tangent and an arc cosine. It's not tan and arctan. So there are a number of ways that you can go about this. Your book or another teacher might teach it differently. I'm just going to teach it to you the way that I think a lot of kids feel the most comfortable. And that's in this case, since we are in the study of trigonometry, go ahead and draw a triangle. Okay, arc cosine is defined in the first and the second quadrants. 2/3 is a positive value, which means I'm going to draw my triangle in the first quadrant. If you think about SOHCAHTOA, cosine is adjacent over hypotenuse. So if this is my angle theta, this would be my adjacent, this would be my hypotenuse. So I need to do Pythagorean theorem to find this value. So I have 2 squared plus my unknown squared equals 3 squared. So 4 plus x squared is equal to 9, x squared is equal to 5. So this value is, in its exact value, it is root 5. So this is the triangle we're talking about, and ultimately what this question wants to know is what is the tangent of that angle? Because remember, if you're wondering, is there an angle that is the arc cosine of 2/3? Yes, but you would have to use a calculator in order to actually find it. Do you need it? No, because I can do the whole problem without physically knowing what the actual degree measure is. I have all of the ratios of that triangle. So in order to find the tangent, I know that the tangent of this angle is going to be opposite over adjacent, TOA by SOHCAHTOA. The opposite is root 5. And the adjacent is 2. On choice B, it's a very similar process. The arcsine is defined in the first and the fourth quadrants. This is negative. That means I'm going to draw my triangle in the fourth quadrant. By SOHCAHTOA, this is OH. So the opposite of that reference angle is -3. The hypotenuse is 5. I'm going to do Pythagorean theorem, and some of you might recognize this is a 3, 4, 5 triangle. 4 is going to be in a positive direction. So again, theoretically, -3/5 is a ratio. This entire statement will output an angle. I don't need to know that angle because I already know its ratios. The question wants to know what is the cosine of that angle. The cosine is adjacent over hypotenuse, and my adjacent is 4 and my hypotenuse is 5. Problems from calculus. This problem is extremely similar to the two we just did, except these are numerical arguments. This is an expression. Our answer will be an expression. It will have an x in it. So we start the same thing. And this is where kids go, Nap. And I am using my name, and this is a virtual course, so sorry. If you don't know me, I'm from Parkway West. Here we go. The sine of the arc cosine of 3x. 3x is a ratio. I know that the arc cosine is defined in the first and the second. So kids will say, well, where do I put my angle? Well, it doesn't matter, because when you take the sine of an angle that is in the first or second quadrant where arc cosine is defined, the sine is going to be positive in both quadrants. So it does not make a difference where I draw my triangle. I'm going to go the first quadrant just because I think it's easiest. So arc cosine, we're looking at adjacent over hypotenuse. So that is 3x over 1. So my adjacent is 3x, and this is 1. I'm going to do Pythagorean theorem again, but remember that this value is going to be an expression, not a concrete whole number. So I'm going to have 3x squared plus my unknown squared. I'm just keeping it a box so you're not confused with the x, and that equals 1 squared. So this is 9x squared plus this dude squared equals 1. This dude squared is equal to 1 minus 9x squared. So then, when I take the square root of both sides, I know that that side is equal to the square root of 1 minus 9x squared. Now, I do understand that from a solving perspective, you do get a plus or a minus principal root, but then when I apply it to my picture, I'm only going to take the positive principal root because my y value is positive. And we do the same thing. Ultimately, this is a sine problem. So that means it's going to be opposite over hypotenuse. The opposite is the square root of 1 minus 9x squared over 1. And certainly, I mean, if a kid wrote it that way, it's full credit, but it's 1 minus 9x squared. Some kids feel like they have to do more algebraically with it, like, oh, it's a difference of 2 squares. Just leave it. There's really no reason to do anything more with that. Okay, now we have a couple of word problems. Different types of granular substances naturally settle at different angles when stored in cone-shaped pile. This angle theta is called an angle of repose. So ultimately here what happens is, this is really a right triangle trig problem. It's put in the inverse. You'll see why, because we're going to have to use the inverse function part of this. But when they want you to find the angle repose for the rock salt, they tell you that the angle, or that in the cone, it is 11 feet high. And if the diameter is 34 feet, that means that the radius has to be 17. So in order for us to find part A, I have the tangent of theta, and that is going to equal 11 over 17. Because I am trying to get theta by itself, I have to undo the tangent. You can't undo tangent by traditional adding, subtracting, multiplying, or dividing. I have to apply an inverse tan to both sides. So theta is equal to the inverse tan of 11, I don't know why I just wrote pi, of 11 over 17. This becomes a calculator problem for you to perform. So we're going to use Desmos to finish this problem. I'm going to type that in order to get my angle. And when I input the inverse tangent of 11/17, we get 0.57, which is a radian measure. So when we go to part B, they want to know how tall the pile of rock salt that has a base diameter of 50 feet. It's ultimately the exact same picture, but now we know that the angle of repose is 0.57 radians. We need to find the height. And if they told us that the diameter was 50 feet, that means that the radius would have to be 25. The height is an opposite value. The 25 is an adjacent value. So this is another tangent problem, but this time we would not use an inverse because we know the angle. We're going to simply use our calculator and type in 25 tangent of 0.57. And we get that the height of that conical pile would be approximately 16. And that would be 16 feet. And for our last question, a crane has a 200-foot arm whose lower end is 5 feet off the ground. The arm has to reach the top of a building 130 feet high. At what angle theta should the arm be set? All right, well, when we look at this picture, if we ultimately look at this triangle, if I'm 130 for the entire distance, I take away 5, so this side's 125. If I use SOHCAHTOA, I know that 125 is an opposite value and 200 is the hypotenuse, so that just screams sine. So the sine of theta is equal to 125 over 200. That's my opposite over my hypotenuse. My goal is to get theta by itself, so in order to do that, I have to take an inverse sine on both sides, and this becomes a calculator problem because it's not an exact value. So use Desmos to find the inverse sine. Of 125 divided by 200, and we get that the angle that it should make is approximately 0.68 or 0.7, however you round radians. Hope you enjoy. You can finish, it's actually 12 since you already did 11 in the previous. Enjoy problems 12 through 30 in the rest of the WebAssign.